A cardboard manufacturer designs a rectangular cardboard container on a rectangular base. The top and sides consist of a single layer of cardboard, and the base of the container is reinforced by using 4 additional layers of cardboard. The length of the container is 3 times the width, and the volume of the container is 864 cubic centimeters. We are required to calculate the dimensions of the container that minimizes the cost. At this point, we only know what the volume of the container must be, so the container could look as illustrated, or it could be shallower, or perhaps more vertically elongated. We have no way of knowing at this point, it is just something to bear in mind for when we arrive at the solution. We will let the width of the base of the container be x. The length of the container is therefore 3x, and we will simply call the height of the container, h. The top surface of the container, the 2 side surfaces, and the front and back surface, all consist of a single layer of cardboard. The bottom surface, however, is reinforced by 4 additional layers of cardboard. We are required to determine the length, width, and height of the container, such that the cost of manufacturing the container is minimal. In other words, we need to calculate the smallest total surface area of the container, such that the volume of the container is 864 cubic centimeters. The area of a rectangle equals the length times the breadth, so the area of the top surface is 3x times x, which equals 3x squared. The area of each side surface is xh, so the sum of these 2 areas is 2xh. And the area of the front and back surfaces, collectively, is 6xh. The total surface area, excluding the base, is therefore 3x squared plus 8xh centimeters squared. The base has a surface area of 3x squared, just as the top surface does. However, the base is reinforced by 4 additional layers of cardboard, each of which has the same area of 3x squared. The total surface area of the base is therefore 5 times 3x squared, which equals 15x squared. The total surface area of the container is therefore 18x squared plus 8xh. In order to minimize the cost, we need to differentiate this expression for the total surface area, with respect to x. This expression also contains the height, h, and we only want it to contain the variable x. We therefore use the fact that the volume must be 864 cubic centimeters, to find an expression for h in terms of x. The volume of a rectangular prism equals the length, times the breadth, times the height. In other words, 3x squared h equals 864. Isolating h gives us, h equals 288 over x squared. Substituting h equals 288 over x squared into the expression for the total surface area, means that the total surface area equals 18x squared plus 2304 over x. To minimize this function, we need to differentiate the expression with respect to x, and equate the result to 0. Recall that to find the maximum or minimum value of a function, we put the derivative of the function equal to 0. Before we differentiate the function though, we need to put it into differentiable form, by expressing 1 over x, as x to the minus 1. Thus, the total surface area equals 18x squared plus 2304 x to the minus 1. We can now differentiate the expression, and equate it to 0. Thus, dTSA dx, equals 36x minus 2304 x to the minus 2. Therefore, 0 equals 36x minus 2304 over x squared. X, which represents the width of the container, obviously cannot equal 0, so we can simply multiply all terms by x squared, and solve for x. Therefore, 36x cubed minus 2304 equals 0. Solving this expression for x gives us, x equals 4. To minimize production costs, the width of the container must be 4 centimeters, and the length, which is 3 times the width, must therefore be 12 centimeters. The height of the container equals 288 over x squared. Therefore, the height of the container is to be 18 centimeters. Since the container is higher than it is long, the container is more elongated vertically than horizontally. The total surface area of the container, for minimum cost, is therefore 864 square centimeters. We can test a few values of x to confirm our answer. Taking the first 12 natural numbers for the width of the container, it can be seen from the table that the smallest total surface area occurs when the width of the container is 4 cm long. We can also confirm the solution graphically by sketching the function y equals 18x squared plus 2304 over x. Since x cannot be negative, we can ignore the part of the graph to the left of the origin. The lowest point on the curve is at the point where x equals 4, which confirms the solution.